Today we're going to begin looking at the graphs of our trig function. So the graph of sine of x. Okay, so if we think back to our unit circle, we know that we start at 0 and we start going around. You've got pi over 6 and then pi over 3. We're skipping the 4s here, it seems. And pi over 2, 2 pi over 3, and so forth. So going through by pi over 6's, if you take the y values of the point that goes along with those angles and plot them on a graph, if you take those points and plot them on the graph, so you're using first the point 0, 0, of course, but then the second point is pi over 6, 1/2. So you're using the x value is your angle, and the y value is the y value of the point that goes along with that angle there. And you plot that point, and you keep going, you get the sine curve. The sine curve has a domain that is negative infinity to infinity, all real numbers, because it keeps doing this wave thing all the way forever in both directions. The range is -1 to 1. Unit circle, remember, the biggest number on the unit circle is 1. And so at pi over 2, we hit 1. At 3 pi over 2, we hit -1. So we're only going from 1 to 1 in the y-axis, unless we do some kind of transformations to move it. But right now we're just looking at the sine curve. The function is an odd function. We've already talked about that. And here's the reason behind that. If you have the sine of a negative number, then you get negative the sine curve of that number. Okay? So if you've got, say, a negative pi over 2, okay, then if you put in pi over 2, you get back -1. So same thing. On either way, you would get -1. For example, it says graph 2 sine of x using transformations. So back in pre-calc algebra, we talked about transformations. And with this one, we've got a 2 in front of the function. So what that means is that we're going to vertically stretch by 2. Let's see what this looks like. First, I'm going to graph the regular sine curve. Okay? For the sine curve, we have 0, 0. We have pi over 2, 1. And then pi 0, and 3 pi over 2, -1, 2 pi 0. So it would look like this. And then going back the other direction, we'd have negative pi, -2, or negative pi over 2, -1, and negative pi 0. So there's our sine curve. But we want to graph y equals 2 sine of x. So what we're going to do is take all our y values, because it's vertically stretching, and multiply by 2. So we would have 0 times 2 is just 0, so we're still there. And then let's go over to the 1. 1 times 2 is 2, so it'd go up here. Then we have 0 again. -1 times 2 is -2, and then we have 0 again. And going back the other direction, we'd end up with a -2 and a 0. So the sine curve, not the easiest thing to graph on an iPad, but I think I'm doing pretty good, where it's multiplied by 2, or y equals 2 sine of x, looks like this. It asks us what is the domain and the range. Well, the domain for any sine curve, unless we've bound it somehow, is always going to be all real numbers. So negative infinity to infinity. The range, the lowest point is -2, and the highest is 2. So our range is going to be including -2 to 2. Cosine x is very similar to sine of x, except sine did like this. Okay? Cosine is basically a phase shift, which we'll talk about what that is later. It's basically a phase shift of sine 1 or pi over 2 to the left. So back to the unit circle. If we go around, the cosine is the x value of those points that go along with the angles of the unit circle. So if we go around, starting with 0, the angle 0, the x value is 1. So that's why we have 0, 1 here. The next point would be pi over 6, square root of 3 over 2. And that is, I think it's approximately 0.866. Don't quote me on that, though. And then pi over 3, 1/2, pi over 2, 0, and so forth. Just going around the unit circle to roll out cosine. Now, the domain, again, is all real numbers because it's going to continue this wave all to the left and the right. And again, the range is from the unit circle. We have a greatest value of 1 and a least value of -1. So the range is, again, -1 to 1. The period, we didn't talk about this back in sine, but the period is the same with sine. A period is where it hits the same point, how far it gets to hit the same y value. So if we started here, where is it going to hit a y value of 1 again? There. So that means the period is 0 to 2 pi, or 2 pi. We could start the period here and go to here. It would still be 2 pi. And same thing with sine. Cosine is an even function. And so, like, if you say cosine of negative pi, that's -1, while cosine of pi is also -1. So that's why it's even. For example 2, it says graph 2 cosine of 3x using transformations. Okay, so let's start, just like we did before. Let's graph our cosine function. So we have 0, 1, and then pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1, and then go in the other direction. So we end up with this. Guys, when you do this for me, please don't do this deal. That is not a curve. Make sure they're curved. That one didn't look very good. Let's try that again. And use a pencil. Nice to be able to erase. Okay, so here we've graphed y equals cosine of x. Next, let's graph y equals cosine of 3x. So we're not dealing with our 2 yet. We're just talking about the cosine of 3x. Well, what does the 3 do? The 3 shrinks horizontally by a factor of 3. Okay, so what does that mean for us? That means that while the period was 2 pi, the period is now 2 pi over 3. It means that our cosine function is going to repeat every 2 pi over 3. So it's going to repeat 3 times inside of our normal period of 2 pi. So our normal period, it repeats once. But since we're multiplying the x by 3, it's going to happen 3 times in there. So let's see what that looks like. So we're starting here at 0, 1 still. And between here and here, we have to divide this into 3. Okay? So pi, between 0 and 2 pi, we have to divide that into 3s. Then we could look at 2 pi over 3 and 4 pi over 3 and see how that divides our graph into 3 sections, 3 equal sections. So what's going on is between here and here, we have to go down and back up. So halfway through there, we have to go down to -1. And then between 0 and pi over 3, so at pi over 6, we have to be at 0. And so at, what is that? At this point, at, let's see, 1 pi over 6, 2 pi over 3 pi over 6. We have to be back at 0. And then up at 2 pi over 3, we're back at 1. And so we just repeat that pattern. And we can go in the other direction too. So that cosine of 3x looks like this. And when I ask you on your lab to graph these by hand, I'm expecting at least 1 period. So I've graphed several periods here, but that's okay. But you would have to graph at least from here to here to give me 1 period, just so you know. And then last, we want to graph y equals 2 cosine of 3x. Now, what does that mean? Same thing it did on the previous example. We're going to stretch vertically by a factor of 2. So all these 1s becomes 2s, and the negative ones become negative 2s, while our zeros stay the same. And so here is our 2 cosine of 3x. And notice how I'm trying my best to curve these. So there we go. What's the domain? All real numbers. What's the range? We're going from negative 2 up to 2. And it's including those. So there we go. Okay, so we just looked at 2 examples of how we can graph our sine and cosine using transformations. There is a general way to do this, okay, and how to talk about the number in front and then the number that's being multiplied by the x. What we do is the number in front is our amplitude, or the absolute value of the number in front is our amplitude. So the number in front, if you take the absolute value of it, that gives you your amplitude, how far up it goes and how far down it goes from its zeros or from its center point. And then B is related to the period. Remember how I said in example 2 that if we took our period and divided it into 3 parts, then that was what was giving us cosine of 3x. That's how we get our period. Whatever B is, we take 2 pi and divide by B, and that gives us our period. Sine and cosine are called sinusoidal graphs. I think I said that correctly. And we pretty much already talked about this. Cosine is a phase shift of sine, pi over 2 to the left. And here are some instructions you can read through for how to graph these. We're just going to go forward to an example. It says determine the amplitude of y equals 3 sine of x. Then graph y equals sine of x and y equals 3 sine of x for negative pi to 2 pi. So, I've got so many blank pages. The amplitude is this number in front. So it's the absolute value of 3, which is, of course, just 3. And let me tell you something. What's the amplitude of sine? What's the number that's imaginary there? A 1, okay? So the amplitude of normal sine curve is 1. Just want to point that out for future reference. Okay, so it asks us to graph the sine curve, so I'm going to do that real quick. Here is y equals sine of x. And y equals 3 sine of x takes that and multiplies the y values by 3. So we still have 0 here. At pi over 2, we go up to 3. At 3 pi over 2, we go down to negative 3. So it looks something like this. What's the domain? All real numbers. What's the range? Starts at -3 and goes up to 3. For example 4, it says determine the amplitude and the period of 2 sine of 1/2 x. Okay, so the amplitude would be the absolute value of this number in front, 2. Amplitude is 2. And it asks for the period. Remember, we find the period by doing 2 pi over b. B is the number in front of x. So we've got 2 pi over 1/2. That means our period is 4 pi. So one rotation is only going to take 4 pi. It's going to be twice as long, actually, to get there. Okay, so we're graphing from 0 to 8 pi. What we want to do, in order to graph this, the easiest thing to do is to find 5 key points. Our 5 key points are found by using the period over 4. Okay, that gives us 5 points for our graph, which gives us a full period. So, if we take our period, which is 4 pi, divide it by 4, then that means every pi is when we're going to hit either 0 or pi over 2, or either a point of inflection or a maximum or minimum. So the first one, sine starts at 0, 0. And so what we do is the next point will be pi, and instead of being 1, it's going to be 2 because we have an amplitude of 2. Then we went from 0 to pi and then 2 pi. So it goes up to 2 and then back down to 0. Then add another pi. At 3 pi, we're going down to -2. And then our last point, add another pi. We have our 4 pi, and we're going back to 0. So let's plot these 5 points. 0, 0, pi 2, 2 pi 0, 3 pi -2, and 4 pi 0. So there is one period of 2 sine of 1/2 x. It wants us to go ahead and graph to 8 pi, so just repeat from there. Not a big deal. You don't have to write down more points or anything like that. What's the domain? All real numbers again. What's the range? It's starting at -2 and going up to 2. Let's look at one more example graphing here. So with cosine of x, the amplitude is still the absolute value of a, and the period is still 2 pi divided by b. Okay, that'll change with tangent and cotangent, but as far as sine and cosine, it's the same. So here, we're first asked to find the amplitude, we've got y equals negative 4 cosine of pi x minus 2. So the amplitude is the absolute value of A, the number in front. So the amplitude is 4. The period is 2 pi divided by B, and there's B in front of our x. So 2 pi divided by pi is 2. And then we'll talk about that minus 2 here in a second. So the first thing that I want to do is talk about our 5 key points for the graph of y equals negative 4 cosine of pi x. We'll deal with that minus 2 here in a minute. So what would our 5 key points be? Take the period, divide by 4. Our period we said was 2. So period divided by 4 is 1/2. So let's think about our 5 key points. So cosine starts at 0, 1. So we've got a few things that are going on here. First of all, there's a negative in front. And that negative tells us that our graph has flipped or reflected over the x-axis. So where we would normally start at 0, 1, we're starting at 0, negative 4. Okay? So it was at 0, 1, and now if it were just a positive 4 there, then it'd be at 0, 4. But since it's negative, we have to flip down to negative 4. Our next key point will be 1/2 units later. And so we've got the next is at 0. Then 1/2 a unit later at 1, it's going to go up to 4. 1/2 a unit later at 1 1/2, it's going to go back to 0. And then another 1/2 a unit later at 2, it's going to go back down to negative 4. So let's see. We've got 0, negative 4. Then it was 1/2 0, 1 4, 1 1/2 0, and 2 negative 4. And then we're just repeating from there. But I think, yeah, let's go ahead and do that. Okay, there we go. So there is y equals negative 4 cosine of pi x. What does that minus 2 do? If we think back to transformations, if you add or subtract on the end, it moves it up or down. So since we've subtracted 2, all we're doing is moving everything here down 2. So this point at negative 3, 4 is going to be negative 3, 2. At negative 2.50, we're going down to negative 2.5, negative 2. Then this point moves down 2. This point moves down 2. This point moves down 2. And so forth. We're just repeating our curve keeping our amplitude and everything, but moving all our key points down by 2. Now we can go back and change our key points a bit. All we'd have to do is subtract 2 from each y value. So negative 4 minus 2 is negative 6. 0 minus 2 is negative 2. 4 minus 2 is 2. And so forth. Okay? So these would be our actual 5 key points of our official graph of y equals negative 4 cosine of pi x minus 2. What's the domain? All real numbers, of course. And what's the range? Well, let's look at this. The lowest point is negative 6. The highest point is 2. So our range is from negative 6 to 2, including both negative 6 and 2. For our last example, we just want to find an equation that would fit this graph. So let's see. We need to talk about the amplitude and the period so far, and if there's any vertical shifts. The amplitude, you can see we're going up to 2 and down to 2. So there's no vertical shift. We've just got an amplitude of 2. This is a sine curve, unless we want to mess with phase shifts, which we don't. So this is the sine curve. How do I know? Because it goes through 0, 0. And then the period is 4. This tells us what b is, because the period is 2 pi over b. So we just take this and solve for b. Basically cross multiply. 4b equals 2 pi. So b is 2 pi over 4 or pi over 2. So now we can now we can write our equation in the form y equals a sine of bx. It'd be 2 sine of pi over 2x. And something I didn't talk about, there's no negative out here because we are going up first. If we were going down first, then we would have to put a negative out front. Just want to point that out. And then for part B, same type deal. Since we're going through 0, 0, then this is going to be a sine curve. It's going up to, looks like 3 and down to 3. So the amplitude is 3. The amplitude is 3, but notice we're going down first. So that means that A is negative 3, because normally sine would go up first. And then all we need now is the period. We see the period here is 8. So we're going to set that equal to 2 pi over b and solve for b. So b is pi over 4. So in the form y equals a sine of bx, we can write y equals negative 3 sine of pi over 4x. And that concludes this section.